Alright, since I can't be with you guys today, we're going to try a little bit something different. We're going to be doing our math lesson from objects I found around my own house. Today we're going to be looking at the surface area of a rectangular prism and the surface area of a cylinder. Now in order to do this, we have to think about what makes up these shapes. Surface area would be the outside, what I can touch on this. Think about if you had a birthday present that you wanted to wrap for somebody. How much wrapping paper is actually being used on that object? That's what we're going to be looking at today. So if we look at these shapes, we're going to start with the rectangular prism. I have just a regular Eggo mini waffle box. This is one of my son's favorites. He really likes the minis. So if we look at this shape, we can tell we've got a rectangle here, another rectangle, but are these the same size? Then we also have a third rectangle on the ends. So what I'm going to do is I'm just going to take this box apart. And we're going to see what we can already start to see that we're starting to create some of these rectangles. So as I do this, what is a three-dimensional shape being represented in two-dimensional form? Somebody raise your hand and let us know. Good, good. Yes, a net. That is exactly what it is. And we can see that the shape of this is now formed. Now, generally, we would have all these small edges here would be more similar to this one on the side here. But because I had already opened this box, it's a little bit different. So what we want to do is, when we're thinking about the net and we're trying to find the surface area of this shape, we look at what we have. If I measure this box, so I have my tape measure, the width of this rectangle is about 9 inches. And just for our purpose, that is what we're going to use. So this is 9 inches. Now, will this 9 inches ever change from here to here, or down to the bottom of this face, to the bottom of that face, to the bottom of that face? Yeah, no, it'll stay consistent. So on every one of these, we know that the long end is 9 inches. So we can label that on each of these. The next thing I want to know is, what is the height of this shape? So if I look, that's about 4.5 inches. So we know that this side is about 4.5 inches. Now what we have to think about is this the same as this one? Just visually we can look at this and picture that that is not the same, that this one looks smaller. So if we measure just that middle piece, we get about 3 inches. So we're going to call this 3 inches. So now if I look again, we know we have two sets of parallel rectangles. When I fold this up, I can kind of see that the rectangle formed here is parallel to the rectangle formed here. So that tells me that if that is correct, that this should also be 4.5 inches. If I look, I have my 4.5 inches again. And then this one must be my 3 inches. So now I've identified all of the bigger rectangles, but now I still have to think about the end piece. Well, if we know that this side is 4.5, that tells me that this piece must also be 4.5 inches. If I look here, what is the width of this piece? We see that it matches up with my 3 inches. Which would make sense because as I fold this up, I have 4.5 at the bottom, and then the piece next to it that folds up is my 3 inches. So there's my 4.5 and there's my 3. And that's what we see in this shape. Now the surface area, to find this, we have to find the area of each of these shapes. Area of a rectangle is found by base times height, which in this case is 9 times 4.5. Well, 9 times 4 is 36. Half of 9 is 4.5. So 36 and 4.5 is 40.5 inches squared. It is still area, so we have squared units. The next piece we have, area equals base times height, equals 9 times 3. My base is 9, my height is 3, so this piece equals 27 inches squared. The third piece, well, we've already done the math here. We have a base of 9, a height of 4.5, so it looks just like this piece here. So we know that this is also going to be 40.5 inches squared. And the last piece matches up with our 9 by 3. 9 by 3, so we know that this one is also going to be 27 inches squared. So when we start looking at what we have, we see that we have 2 rectangles that are 40.5 inches, 2 rectangles that are 27 inches squared. The last thing we have to do is account for the 2 end pieces. Area equals base times height, which is 4.5 times 3. 4 times 3 is 12. Half of 3 is 1.5, so that is 13.5 inches squared. And now we know we have the other one that is 13.5 inches squared on the other side. So we'll just do the one that's across. Even though this isn't the full piece, we realize that this must be a full piece. This is where the opened end of the box was. Now when we're doing this, to find that total surface area, we're going to have to add up all of these numbers. So we had 40.5 plus 40.5 is going to be 81 inches squared. We had the 27 plus 27 is going to be 54 inches squared. And we had the 13.5 plus 13.5, which is going to be 27 inches squared. So now what we've done was, essentially we said 2 times the width of the shape times the height of the shape. Width times height got us our 13.5, and we had 2 of them. We have 2 times the width times the base of the shape. And we got our 27 multiplying the width times the base. 2 times the base times the height of the shape. We add all of those together. 27 plus 54 plus 81, and we get a total of 162 inches squared for our surface area. What I would like you guys to do at this point is I'm going to show you a picture. I would like you to try to solve this problem. Take a moment to write this down. You can pause the video. Now, I drew out the net so you could see this. Notice how we have this thin rectangle on the side and the height. And you have almost what looks like a square here. And we can tell that's pretty close to square, 16 millimeters by 15. So that's going to appear to be a square even though it is still a rectangle. drawing out the net is a good way for us to visually see what's going on in this problem. You may want to use this and go through and label each of the pieces so that you can figure out what your total surface area is. You can see that now I've gone through and I've added my numbers in. I also added the color in, so visually it could help me see this a little bit better. So I could see my yellow piece here is 15 by 5. So when I look here, I know 15 and 5. So to find the area of the yellow, I would find area equals 15 times 5, which 10 times 5 is 50, 5 times 5 is 25. So this has an area of 75 millimeters squared. This is also going to work for that yellow piece. The pink piece is going to be 16 by 15. And when I do this, I know, just because I know my square roots, that 15 times 15 is 225. So if I have one more group of 15, that would be 240 millimeters squared. And again, that would be the same for this piece, 240 millimeters squared. My last piece, this blue, now this is another reason why I really like the color, because I can see over here that now I see that 16 and 5. So I know that this has a height of 16 and a width of 5. So that's going to be 16 times 5, which again, I've already done the math here for 15 times 5, so I know it's just 5 more than that, which is going to be 80 millimeters squared. And this is for this blue and this blue. Now, just like our waffle box, we see that we have 2 of each dimension listed. I have 2 pink, I have 2 blue, I have 2 yellow. So the idea here is we can find a more efficient way of doing this. That if I know, and let me relabel over here, that if this is my base, the yellow is my width, and this piece right here is my height, I can see that I have base times height times 2, so 2 times the base times the height, plus my yellow is my width times the height, and I have 2 of those, so 2 times width times height, and finally I have 2 of the blue, which the blue is the same as that base on the pink and same as the width on the yellow, so that's going to be 2 times the base times the width. 2 times my base was 16 times my height, which was 15, and I can see I did the 15 times 16 twice. This is going to equal 480 plus 2 times the width, which is 5, times the height, which is 16. Again, the height is 15. That's my yellow pieces here, and we've done that. So when I multiply that by 2, I get 150, and 2 times the base, which is 16, times the width, which is 5. We know that that was our 80, so if I multiply that by 2, I get 160. Now when I add all of this together, 480 plus 150, that's going to be 580. 630 plus 160 is going to be 790 millimeters squared for my surface area. Now that we've looked at the surface area of a rectangular prism, we've talked about how when we see that net, we find the different figures that are within it, and we notice that there are two of each. We want to move into the cylinder. So again, I just found something around the house. This happened to be a breadcrumb container, but it is our cylinder shape. So what I'm going to do is I'm going to take the top of it off. Before we do that, if we look real quick, we see we have a circle on both ends, and then it's just a smooth side around. So I take my top off, and I'm going to go through, I'm going to cut down the side so that we can look to see what happens with this shape. And now I've cut the side, but we can see that I can't unroll this or open this because it's not all the way. I've only cut it one direction. So what we're going to do is we're going to cut along this circle. And as I'm doing this, we can kind of see that the shape will start to naturally unroll. And we've made a rectangle. So when that rectangle rolls up, that's what gives us our smooth side. So it's one rectangle used for the entire side, and then we have two of these circles that are used as our caps, making it a cylinder. So when we think about this, this is even easier than the rectangular prism because all I have to worry about is finding the area of this one rectangle and the area of the circle, and then multiply that times 2 because we had the one on each end. The hard part about this, and we'll start with thinking about the area of a circle. And for our purpose, I'm just going to tear this off so that we can do our work on it. So if I think about what I have, area of a circle is found by pi times radius squared. Pi times radius squared. So I'm going to measure my circle, and now I've cut it up a little bit so I know it's not perfect, but that's roughly 3 inches from one side through the other. This is 3 inches. So that is my diameter of 3. But again, remember we want the radius. So this is going to be 3.14. Half of 3 is 1.5. So times 1.5 squared. So I have 3.14 times 1.5 squared. When we do this, we get 3.14. 1.5 squared is going to be 7.065. 7.065. Working with this, we're going to round to the nearest tenth. So this is going to be approximately 7.1 inches squared. Approximately 7.1 inches squared. So as we go through this, we'll have to think about what we need to do with that number. Now, this is the tricky part. I can easily find the height of this. I can measure that. So if I measure the height of this, it's roughly going to be about 7 inches. So we can write that is going to be roughly 7 inches. But now how do I find the width of this rectangle? Because it was curved. What do we know about the circle that could help tell the width of this shape? Well, if we look at it like this, in this form, I see my circle that matches up with my rectangle when it's folded, and this would form the circumference of my circle. So when I unfold it, that circumference is going to be the same as the width. So what I have to do first to be able to figure out what this width is, I need to be able to figure out the circumference of the circle. And I find the circumference by multiplying 2 times pi times the radius. 2 times pi times the radius. So we've already figured out that the radius we were using was 1.5 inches. 1.5 inches. So we have 2 times 3.14 times 1.5. And if I just grab, I'm using my phone for a calculator right now, 3.14 times 2 times 1.5. And again, I multiplied in a different order, but the commutative property tells me that the order does not matter, and I get a 9.42 inches. Circumference, one-dimensional, so it's just in one form of inch. We're going to round that to the nearest tenth, and we get 9.4 inches. 9.4 inches. So now I know my base is 9.4. I know my height is 7. So I can find the area of this rectangle by the base times the height, which is going to be 9.4 times 7. And we get 65.8 inches squared for my area of this rectangle. Now, if we want the whole surface area, we would have the area of the rectangle, the area of the circle at the base of the object, and the area of the circle at the top. So I would have 2 areas being added to the circumference of the circle times the height. Circumference is found by 2 pi radius times the height plus 2 times the area, which is pi times radius squared. We already found the circumference, and we already found what that is times the height. So we know that this is 65.8 plus 2 times our area, which our area, if you recall, was our 7.1 inches when we rounded it. So this is going to be 65.8 plus 14.2. Well, I know that 8/10 plus 2/10 is a whole. That makes that 15 plus 4 plus 1, 5 plus 4 plus 1, which is 10, and 7 plus 1 is 8. So 80 inches squared. Again, we took the area of the radius of the circle times 2, because we had the base of the shape and the top. We use the circumference, that distance around our circle, to figure out the distance or the length of our base, and we multiplied that times the height. When we added that together, we got a total surface area of our 80 inches squared. If we look at a problem, we have this problem right here, and you can see I drew out a net again. If you will, again, I added some color to mine. So I've gone through and I wanted to see this a little bit more. I can see that I have a circle with a radius of 2 feet, a height of 10. So I see I have the top circle, the bottom circle, and then this rectangle. So as I go through trying to figure out the math that I need to do, I know that I want to find the area of this, the area of this, but I need the circumference to tell me how to find the area to give me both measurements I need. So surface area equals the circumference times the height. That is going to give me my yellow portion plus 2 times the area, which that'll give me the blue portion. Before I can do circumference, I have to figure out what that is. So I know circumference is 2 times pi times radius times the height, and I know that my area is pi times radius squared. 2 times 3.14 times the radius of my circle, which was 2, and the height of my shape, which is 10, plus 2 times 3.14 times the radius of my circle squared, so the 2 squared. When I go to do this, again, I'm just going to find my calculator. 2 times 3.14 2 times 3.14 times 2 times 10. It's going to be 125.6 plus 2 times 3.14, 2 times 3.14 times 2 squared. Since I don't have a squared on this, I'm just going to multiply it by 2 again, and I get 25.12, which if I round that to the nearest tenth is 25.1. Now I just add these together and I get 150.7 inches squared. In order to make sure that you have the formulas, I've written them down here again so that you can look at them as you work through some practice today. For a rectangular prism, we find surface area by multiplying 2 times the base of the shape times the height of the shape, plus 2 times the base times the width, plus 2 times the width times the height. For cylinders, surface area is found by the circumference times the height, plus 2 times the area. Or, if we think about what the formulas are, 2 times pi times the radius times height, plus 2 times pi times radius squared. Be sure that you get these written down so that you have them to use in your practice.